Imagine a hole in the ice of Antarctica, a hole so vast it could swallow the entire country of Switzerland. Sounds like something out of a science fiction movie, right? But this is real, and it's one of the most baffling mysteries our planet has to offer. This isn't just any crack in the ice. It's a massive, recurring phenomenon known as the moored rise Polynya. It appeared, vanished, and then, after 40 years of silence, it came back with a vengeance. What is this colossal hole? Why does it keep appearing? And what does its return mean for the rest of the world? Stick with me, because we're about to dive deep into the icy heart of Antarctica to uncover the secrets of this phantom ocean. Let's travel back to the 1970s. Satellites, our new eyes in the sky, were just beginning to map the most remote corners of our planet. In 1974, over the Weddell Sea in Antarctica, they spotted something completely unexpected. A gigantic opening in the sea ice, an area of open water where there should have been a solid, frozen sheet. It was roughly the size of Oregon. This anomaly, which scientists named the moored rise Polynya, persisted for 3 consecutive winters, from 74 to 76, before it vanished as mysteriously as it had appeared. For decades, it remained a ghost, a legend in oceanographic circles. Scientists were left scratching their heads. They knew it had happened, but the why and how remained locked away in the planet's coldest, most inaccessible region. For the next 40 years, it was radio silence. The Polynya was gone. Researchers kept watch, but the ice remained stubbornly whole. It was as if the event had been a one-off fluke, a brief glitch in the Antarctic system. But then, in 2016, something started to change. A small opening appeared. It was interesting, but not nearly the scale of the 1970s event. But the following year, in 2017, the ghost returned in full force. The hole didn't just reappear. It exploded in size, growing to a staggering 30,000 square miles. That's larger than the state of Maine, bigger than Scotland, and as I mentioned, easily big enough to fit Switzerland inside. The reappearance of the moored rise Polynya was a massive event, and this time, we had far more advanced technology to study it. The mystery that had been dormant for 4 decades was suddenly wide open again, and the race was on to finally understand what was going on. So, how does a hole the size of a country just open up in the middle of a frozen ocean? The answer isn't simple. It's a complex dance of wind, water, and underwater geography. The key player here is a feature on the ocean floor called moored rise. Think of it as a massive underwater mountain, or seamount, that rises from the depths of the Weddell Sea. This underwater obstacle plays a crucial role in directing the flow of ocean currents. In this part of the world, there's a powerful circular current known as the Weddell Gyre. As this current flows over and around moored rise, it creates turbulence and eddies, much like a rock in a river creates swirling patterns in the water. This turbulence is the engine that drives the formation of the Polynya. But the mountain alone isn't enough. You need the right ingredients in the water itself. The ocean isn't a uniform body of water. It's layered, with different temperatures and salt concentrations at different depths. Deep down in the Weddell Sea, there's a layer of water that's warmer and, crucially, saltier than the water at the surface. Normally, this warmer water stays trapped deep below the cold, fresh surface layer. However, when the Weddell Gyre becomes unusually strong, the turbulence it creates over moored rise becomes powerful enough to churn the ocean. This process, called upwelling, acts like a giant pump, bringing that deep, warm, salty water all the way up to the surface. And that's when the magic or the science happens. Now, you might be thinking, wait, warm water melts ice. That makes sense. And you're right, but it's a bit more complicated than that. The salt is just as important as the heat. As we all know, salt lowers the freezing point of water. It's why we put salt on icy roads in the winter. When this incredibly salty water from the deep ocean reaches the frigid Antarctic surface, it mixes with the surface water. This new, saltier mixture now has a much lower freezing point, even in the extreme cold of the Antarctic winter, where temperatures plummet far below freezing. This salty surface water refuses to turn to ice. So, while the surrounding ocean freezes solid, this specific area remains a patch of open water. The Polynya isn't just melting from below. It's being prevented from freezing at the surface in the first place. This process becomes a self-sustaining cycle. The open water of the Polynya is directly exposed to the brutally cold winter air. This causes the surface water to lose its heat and become much denser. Being denser, it sinks. This sinking action creates a convection loop, pulling even more of that warm, salty water up from the depths to replace it. It's like a natural chimney, constantly venting the ocean's deep heat into the atmosphere and keeping the hole open for months on end. The events of 2016 and 2017 were triggered by an unusually intense period for the Weddell Gyre, which supercharged this entire upwelling and convection process, leading to the colossal Polynya we saw. Okay, so a giant hole opens up in Antarctica. It's a fascinating scientific puzzle, but does it really matter to the rest of us? The answer is a resounding yes. These Polynyas are not just local oddities. They are critical components of the global climate system. They act as windows between the deep ocean and the atmosphere. Remember that convection cycle we talked about? As the cold, dense, salty water at the surface of the Polynya sinks, it doesn't just stay there. It begins a long, slow journey, creeping along the ocean floor as part of a massive global conveyor belt of ocean currents. This process is called thermaline circulation, driven by temperature and salt. The water that sinks in the Weddell Sea is some of the densest in the world, and it can travel for thousands of miles across the globe, carrying with it signals of the Antarctic climate. This has huge implications. This circulation helps distribute heat around the planet, shaping weather patterns and climates far, far away from Antarctica. The formation of a massive Polynya essentially opens a massive valve in this system, releasing huge amounts of ocean heat into the atmosphere and injecting a massive pulse of cold, dense water into the deep ocean. Scientists are still working to understand the full extent of these impacts, but it's clear that what happens in the Weddell Sea doesn't stay in the Weddell Sea. Changes in the frequency or size of these Polynyas could have long-term cascading effects on global ocean circulation and, by extension, the entire world's climate. As our planet continues to warm, the future of the moored rise Polynya and others like it is uncertain. Climate change is altering wind patterns and ocean temperatures, which could make the conditions for Polynya formation more or less likely in the future. Some models suggest that melting glaciers could release more fresh water into the Southern Ocean, which would make the surface layer less salty and more stable, potentially suppressing Polynya formation. Others suggest that changing winds could strengthen the ocean gyres, making them more common. It's a complex puzzle with huge stakes. Studying these phenomena is crucial for improving our climate models and predicting how our planet will respond to ongoing changes. The moored rise Polynya is more than just a hole in the ice. It's a natural laboratory, giving us a rare glimpse into the powerful and mysterious forces that govern our world as oceans and climate. The story of the moored rise Polynya is a perfect example of how much we still have to learn about our own planet. It's a reminder that even in the 21st century, Earth is full of mysteries waiting to be solved. From a ghostly image on a satellite screen in the 70s to a global climate driver studied by state-of-the-art technology, this phantom ocean in Antarctica continues to captivate and challenge our understanding. Its comings and goings are a pulse, a heartbeat from the deep ocean, telling us a story about the intricate and delicate balance of our world. Thank you so much for joining me on this journey to the bottom of the world. If you found this as fascinating as I do, please hit that like button and consider subscribing for more deep dives into the wonders and mysteries of our planet. Let me know in the comments what you think about this incredible phenomenon. See you in the next video.